All right, so now we're going to be working a little bit backwards. Now we're going to be given a probability or an area under the curve. And then we're going to find a z-score. And then we're going to do that to find a x value, okay? So working backwards. All right, so to find the area to the left of a particular z-score, we're just going to use the table and we're going to look for the area closest to the one provided. All right. If we're given an area to the right of a particular z-score, we'll have to subtract from 1 to get that area to the left, and then we'll look for the closest one. If we're given an area between two z-scores, we're going to use a little formula. We're going to do 1 minus the area given and divide by 2, and this will give us our negative z-score. If we're given the area to the right and the left of two z-scores, we're going to do the area given, divide by 2, and this will give you a negative z-score. So we're going to look at some examples of what I mean by that above. Okay. All right, so let's do some examples. Find a z-score with the following description. Okay, so I'm given the area to the left is 0.7357. Okay, if this area given to me is greater than 0.5, I know I have a positive z-score. All right, so I'm going to go to my table where I'm at the positive z-score, and I'm looking for 0.7357 in the table. So I'm just going to hunt, oh, there's 0.73, and here's 0.7357. So that exact area is given here. Okay, so to find the value of z, I'm going to look to the left, and then above, and I'm going to put these two numbers together to represent that z-score. So z would equal 0.63. Okay. All right, next, the area to the left is 0.20. Okay, so if this value given to you is less than 0.5, I have a negative z-score. Okay, so I need to go to the other table where I have negative z-scores, and I need to find something close to 0.2. Okay, so I'm looking and I'm looking. All right, here's 0.2005. It looks like 0.2 would land right in between these values. Okay, so I just want to pick the one closer to 0.2, and 0.2005 is closer. So I'm going to look to the left and then up. So for this one, my z-score would equal negative 0.84. Okay. What z-value represents the 90th percentile? Okay, 90th percentile represents an area where 0.90 is below a particular z-score, and 0.10 is to the right. Okay, that's the 90th percentile right there. So this means the area equals 0.9. Okay, so that's over half. So I'm going to go to the table that has positive z-scores, and I need to find an area close to 0.9. All right, so I'm looking at my table here. I'm looking for 0.9. So it would probably land between these two. Okay, so which one is it closer to? It's closer to this one. So that would be a z-score of 1.28. All right. So this has an area to the right is 0.0096. So let's 1 minus 0.0096. This gives me 0.9904. So this is a value I should be able to find on my table. So let's go back to the table. 0.9904. Let's see. Oh, there we are. All right, so this has a z-score of 2.34. All right, for the next example, we have a z-score between, where's my pen? There we go. All right, negative z and positive z, the area between them is 0.90. Okay, so to find the remaining area, that's 0.10. So 0.10 is going to be this area plus this area. It's double. All right, so to find an area just to the left of this z, to find this, now I have to take that and divide by 2. So I want to find a z-score that has an area to the left of 0.05. Okay, so going to the negative table, 0.05. Okay, so I have 0.0505 and 0549. So my value of 0.05 is going to fall directly in the middle of these two. It's not closer to one or the other. So when that happens, I'm going to find the average of these z-scores. Okay. All right, so I have, where's my thing? Negative 1.64 and negative 1.65. So if your area falls directly in between two different z-scores, I'm going to find the average. I'm going to take negative 1.64 and negative 1.65, add them together and divide by 2, and I'll get negative 1.645 for my z-score. This is the only time we'll have 3 decimal places for a z-score. Okay. All right, next, the area to the left plus the area to the right is 0.1616. Okay. So now this area to the left and this area to the right combined is 0.1616. So to find just one area, I'm going to divide by 2, and that gives me 0.0808. All right, so let's find 0.0808. Nope, there it is. All right, so I have negative 1.40, and that's my z-score. All right. Okay, so now let's do a few problems. All right, this says heights of river birch trees at a large nursery are approximately normally distributed with a mean of 92.3 and a standard deviation of 4.1. What is the cutoff height for birch trees in the tallest 10%? Okay, so the tallest 10% means this area to the right is 0.10. So this area to the left is 0.9. I need to find a z-score. Okay, so I'm going to go to the positive table and find the area closest to 0.9, which we actually did this problem earlier. It's right here. Okay. So my z-score is 0.8997. Okay, it's asking for a cutoff height, which is an x value. Okay, well, I know z equals x minus a mean over standard deviation. I have a z-score, I have a mean, and I have a standard deviation. So I'm going to use this formula to solve for that x. So I'm going to plug in z, and I'm going to set it equal to x minus the mean, which is, where'd it go, 92.3, and divide by that standard deviation. And I have to solve for x. So I multiply both sides by 4.1. All right, so when I multiply, I get 3.68877, and this equals x minus 92.3, and then I'm going to add 92.3 to each side. All right, and so my final answer is 97.548, and that is my x value, or the height I'm looking for. Okay. All right, for this next question, it says body temperatures are normally distributed with a mean of 98.6 and a standard deviation of 0.73. What temperature represents the 85th percentile? So 85th percentile means the area to the left is 0.85. Okay, so we're going to go to our table and find the number closest to 0.85, which is right here. Okay, so this z-score is going to be 1.04. All right, so z equals 1.04. So I'm going to use that formula again to solve for an x value. So z is 1.04. It equals x minus the mean divided by the standard deviation. We multiply by that denominator first. And then we add this number here. All right, and that will leave us with 99 point, and I've got a bunch of decimals here, 3592 is my answer. All right, for the next question. All right, we have a mean of 77.9, standard deviation of 2.4. What is the third quartile for water temperatures in this region? Okay, third quartile talks about 75th percent. Okay, so I'm looking for an area to the left being 0.75. All right, so close to 0.75 here. All right, looks like 0.7486 is going to be closer than 0.7517, so that z will be 0.67. All right. All right, so we're using that formula to solve for x. So I'm going to say 0.67 equals x minus 77.9 over 2.4. So I multiply by 2.4 on each side. So I get 1.608 equals x minus 77.9. I'm going to add 77.9. So my answer here is 79.508. Okay. All right, next question. During the racing of Talladega Superspeedway, the mean speed of the cars racing were 158.9 with a standard deviation of 6.7. What speed represents the 30th percentile? All right, so 30th percentile is below average, so this would be 0.30. So now I'm looking for a negative z-score close to 0.30. All right, so here we go. Oh, didn't mean for that to happen. That's 0.03, and I need 0.3. Excuse me. All right, close to 0.3. 0.3015 is the closest one here. So that's a z-score of negative 0.52. All right, so I'm going to do negative 0.52 equals x minus the mean over the standard deviation, multiply by that denominator. All right. And then hold on, 6.6. So this is, where's my pen? Negative 3.484 equals x minus 158.9. We're going to add that 158.9 to both sides. So my final answer will be 155.416. All right. And then for this last question, we want to find the top 5% of finishers. So this area would be 0.05, which means this area would be 0.95. All right, so now I need to find an area to the left close to 0.95. All right, so I need to find the z-score in between these two things since neither one of them is close to that value. So I'm going to find 1.64 and 1.65 and divide by 2. So that's 1.645 as an area for a z-score. Okay, so we're going to say 1.645 equals x minus the mean, divide by that standard deviation. Okay, we're going to multiply and then we're going to add 158.9 to each side. So our final answer is 169.9215.